So we have seen that given an ambiguous grammar, we are getting two parse trees. Therefore, what should we do about such grammars? Should we not use them in the compiler design completely? It turns out that some of the ambiguous grammars can be converted to unambiguous grammars. This is called disambiguating rules, which means we can use some rules and see what is the reason for the ambiguity, and if we can work on that root cause, maybe by converting the grammar we could do it. For example, this grammar e derives e plus e, we have seen this just now, right? E star e id. This grammar, we have seen that it is ambiguous, right? And now if you see the reason for it being ambiguous, if I take a string id plus id plus id, for this string we will get two parse trees. One parse tree is e derives e plus e, isn't it? And e derives e plus e, and id and id. And other parse tree is for the same string e derives id plus id plus id. Other parse tree is e derives e plus e, and then the second e derives e plus e. This one is id, this one is id, and this one is id, right? So for the same string we got two parse trees. Maybe if we take one more string, then it will give us some more insight about it. We got some insight here. I want to see some more. id plus id star id. If this is the string, let us see what are the two parse trees we get. One parse tree is e derives e plus e, and second e derives e star e. Okay, and now every terminal has to be even generated by the tree. So this is id, and this is id, and this is id. So this is nothing but id plus id into id. So one more parse tree is e derives e star e, and then this e derives e plus e. This is id, this is id, and this is id. Okay, so we got two parse trees here, and we got two parse trees here. So even if we get more than one parse tree for a given string, we can stop there and say that the grammar is ambiguous, which means even here we can say that the grammar is ambiguous. But then I needed something more. So let's see the reason why for this string we got two parse trees, and why for that string we got two parse trees. Here we have id plus id, and whenever there are two operators on the either sides of an operand, for example, there are two operators on the other side of this id, which operator should I associate this with? If I associate this with the left side operator like this, then it is called left associativity. If I associated this with right side operator, then it is called right associativity. In case of plus, the final output doesn't depend on what the actual associativity is in case of addition. But if you consider this to be a subtraction or some other operation like division, then definitely there will be a change. So in that case, I want plus to be left associative. See, only for plus associativity doesn't matter, but still plus is left associative, which means if I have two pluses, here plus and here plus, here plus and here plus, the leftmost should be evaluated first. Therefore this parse tree is right. Why? The leftmost plus is evaluated first, and this parse tree is wrong. The reason is the rightmost plus is getting evaluated first. So this grammar failed because the rules of associativity failed completely. And then let's look at this example. In this example we got two parse trees. The reason is, in this parse tree, star is getting higher precedence. When we have two different operators of different precedences, then the highest precedence one should be evaluated first, which means, see this has to be evaluated first, star has to be evaluated first, here it is evaluated first, therefore this is right. And what about this one? This is wrong. The reason is, in this one plus is evaluated first, therefore this is right and this is wrong. So here we got two parse trees because precedence is not taken care. here we got two pass trees because associativity is not taken care. If we can take care of these two things, then the grammar can be unambiguous, right? So how can I modify the grammar so that we can take care of these two things? Let's talk about associativity first. So why are we getting both the associativities is we are defining the grammar without any order. See this? Now according to that grammar, I can write expression to be expression plus expression, and if I want one more plus, I could either go this direction or I could go this direction. But then we found out that if we grow in this left direction, if we grow in this left direction here, if we grow in this left direction, then it is going to be left associative, right? And if you grow in right direction, it is going to be right associative, right? So I want the left associativity, therefore I want to restrict the grammar to grow in only one direction, which means I want to apply the recursion only in one direction. For that reason, if I write E derives E plus ID, if this is the grammar or ID, let's see what happens. Here what happens is I am going to restrict the growth of the pass tree. So I am completely restricting the growth of the pass tree. See this? E derives, if I want ID plus ID plus ID, ID plus ID plus ID, then I am going to write it as E derives E plus ID, and there is no other way I could grow. I could only grow it in the left hand side, which means again E plus ID, and finally this E is ID, which means I am growing in left direction because the grammar is defined as left recursive. That is the reason why I am growing like this. So is there any other possibility of getting one more pass tree for the same string? There is no way. This is the only pass tree. Therefore, if I have to see that the operator should always be left associative, I have to see that the grammar has to be left recursive. If the grammar is left recursive means the leftmost symbol in the RHS is equal to LHS. The leftmost symbol in the RHS is equal to LHS. Therefore, if the grammar is left recursive, then the operator will be left associative. You can take any operator and see. See, if you have even one more ID plus ID, one more plus ID, then also it has to be evaluated this one first and this one first and then this one, which means it has to grow this way only, right? E plus ID and then ID. Therefore, in order to fix the first problem, what is the first problem? That we are not following the associativity. We have to define the grammar to be left recursive. Okay, and coming to the second problem, we want to see that when there are two different operators, the highest precedence operator should be at the least level, then only it will be evaluated first, because whatever is at the last level we are evaluating first and then coming up. Therefore, if we have to fix this problem of having different precedences, you define the grammar to be of different levels, which means if I have plus and star in the same grammar, I want to see that plus will be at the higher level and star will be at the next level, like this. If I have plus and star, if I write like this, E derives E plus T. E plus T means E is defined as left recursive, so that plus will be left associative, and then T derives T star F, which means star is nothing but left associative because T is, this production is defined as left recursive. And now so by having these two levels, what happens is if I have plus and star in expression, I don't have any other choice. I have to first derive the plus, then only go for star. Why? Because I have only this option, right? E derives E plus T and then T derives T star F. I don't have any other option here, isn't it? I cannot directly go to T without using this production. If I use this production, definitely I have kept plus. And once you have reached T, you can never reach plus. The reason is T can never generate a plus. Are we getting this? See, the reason is once you have reached T, this point, you can never reach any, you can never generate any star. Therefore, if we have many pluses in the expression additions, they will all be generated at the higher levels. Once you reach the level of star, you could again never generate plus. Now if I write like this grammar is right, but there is a small problem here. What if the grammar does not contain any plus at all? Therefore, to bypass the entire plus, if you directly want to go to star, I am going to write E plus T or T, and I am going to write T star F or F, and F derives ID. Why? Because a grammar might not contain any plus, or a grammar might not contain any star. So understand this, I am writing every production to be left recursive because every operator here is left associative. And second thing is, I am defining two levels in such a way that once I reach the second level, I will never generate plus. Or if I have to generate plus and star in the same expression, I'll finish generating the pluses in the higher level and then go to the star in the next level. Okay. So in this particular example, if you have to generate ID plus ID star ID, then what happens is E will derive E plus T, and then T will derive T star F. You will not get any other combination other than this. Therefore, the grammar is unambiguous. So we have seen two rules. The grammar failed because it is not taking care of associativity and precedence. In order to define associativity, we are defining recursion. In order to define precedence, we are defining levels. Let us assume that we have one more operator, raised to the power of, which means 2 raised to the power 3 raised to the power 2, and this can be written as 2 raised to the power 3 raised to the power 2. If you are writing like this, this is actually right associative. The reason is, if I have such an expression, I have to evaluate 3 raised to the power 2 first and then 2 raised to the power 9 next. It is not like 2 raised to the power 3 and then this, which means it is right associative. If you want an operator to be right associative, then the tree should grow rightwards. That is the reason why for this, if I have to add one more operator, let us say F derives, I have to add raised to the power of. What is the recursion I should define here? The recursion we should define here is right recursion. Why? Because the operator is right associative. Therefore, G raised to the power F or G. Yeah, see, if you see this grammar, if you have plus, star and raised to the power in the same expression, which one should get the highest precedence? Raised to the power of, which means which one should be generated last in the last level? It is raised to the power of, right? And then star and then plus. Therefore, if I have plus, star and raised to the power of, first we'll generate all the pluses. The reason is, once we go to T and start generating star, there is no way we could go back to E and generate plus. Therefore, this grammar ensures that all the plus will be generated first, and then all the stars will be generated first, and then all the raised to the power of. Therefore, raised to the power of symbol will get the highest precedence, which means this symbol is going to be at the least level if you have an expression, and then star is going to be the second least and plus is going to be the closest. Therefore, the operator which is closest to the start symbol will have the least precedence, and the operator which is farthest away from the start symbol will have the highest precedence, right? And if you observe this, I defined plus to be left recursive. Therefore, plus is left associative and then star is left associative, but raised to the power is right associative. Exponentiation operation is right associative. So if I have more than one plus, the only way I could grow is to the left side. If I have more than one star, the only way I could grow is left side. If I have more than one raised to the power of, the only way I could grow is right side. Therefore, all the operators have been set according to the associativity, one thing, and second thing is according to the precedence. So this grammar is perfect and it is unambiguous. We shall take some other grammars and see if we could apply the same thing or not. See the next example. If I have Boolean expressions, right? So a Boolean expression can be ORing of two Boolean expressions, a Boolean expression ORed with a Boolean expression, or a Boolean expression ANDed with a Boolean expression, or it is negation of a Boolean expression. which means whatever is the not, okay, or it can be simply true or false. Now see this, a boolean expression can be ORing of two boolean expressions, or ANDing of two boolean expressions, or a not, negation of two boolean expressions. Now there are three operators, OR, and not, and the terminals are true and false along with these operators, right? Now which one should get the highest precedence? Accordingly, it should get not should get the highest precedence, which means not should be defined at the least level. What is the next highest precedence? And what is next highest precedence? Or. What about the associativity of or and? They are left associative, right? Therefore the grammar has to be left recursive. What about this other one? There is no associativity because it is a unary operator, right? So for this grammar, if I have to disambiguate it, if I have to go for an ambiguous grammar for the same grammar, then I should write like this. A boolean expression can be a boolean expression or something f, and then f can be f and g or g, and g can be not g or true or false. By writing like this, first thing is we have followed the associativity rule, which is left associative. That is why we define it as left recursive. And second thing is we have followed the rule that the highest precedence operator should be farthest away from the start symbol. Since the start symbol is e, I am putting not at the farthest position, and then the lowest precedence should be closest to the start symbol. Therefore this grammar is unambiguous. So let's see one more ambiguous grammar, and then try to convert it to unambiguous grammar. So the grammar is, we have just seen this. A regular expression can be sum of two regular expressions, or concatenation of two regular expressions, or clean closure of regular expressions, or A or B or C, right? So how are you going to convert it into unambiguous grammar? Is same rules. Which one should get highest precedence? Here highest precedence should be given to clean closure, next highest precedence should be given to concatenation, and next highest precedence should be given to union. Therefore the least one is union. So I am going to write it like this: E derives E plus. So when I am changing the variables, the language doesn't change. Therefore the variable names doesn't matter. Don't worry about it. Either R or E, nothing, no problem, right? And E derives E plus T or T. Why? Because the least precedence is union operation and it is left recursive because it is left associative. And then T derives TF or F, and then F derives F star or A or B or C. Okay, so that is how this grammar is again converted into unambiguous grammar. So let's see one more example. Now given a grammar, you can find out whether it is ambiguous or unambiguous, and if I give you any unambiguous grammar, you could even say the precedence rule. So let's say one example is this. It is one of the previous GATE questions. One example is A derives $B, B derives B hash C, C derives C at the rate D or D, and then D derives small d. Okay, so in this what do you understand about the associativity and precedence of various operators? This dollar, star and at the rate are operators, and D is also a terminal. Okay, it is an operand. So small d is an operand, and dollar, hash and at the rate are operators. So if you look at this, the grammar is defined as left recursive. Therefore dollar should be left associative, isn't it? And then again hash is defined as left recursive. Therefore hash should be left associative, and at the rate is also defined as left recursive. Therefore at the rate should be left associative, isn't it? Therefore if I have in an expression $2 side by side in the sense there are some operands in middle. If I have $2 operators in an expression, which one should be evaluated first? According to this grammar, it is saying that if you have $2, left one should get highest precedence because it is left associative. Therefore I am going to write like this. So this is just a notation to denote that left side star is having higher precedence than right side star. and if I have two hash symbols, then which is going to get the highest precedence? Since it is defined as the left recursive grammar, therefore it is left associative. Left one should get the higher precedence, right? And if I have two amp at the rates, which one should get the highest precedence? The left one, right? And now compare all the three operators once again. Which one is having the least precedence? Dollar is having the least precedence. Which one is having the next least precedence? Hash. Which one is having the next least precedence? At the rate. Therefore, in the order of precedence, the highest precedence will be given to at the rate, and the next highest precedence will be given to hash, and the next highest precedence will be given to dollar. So this is how the operators are can be evaluated. Now one of the gate question is this. So given this grammar E derives E star F plus E, or F derives F minus F or ID. Tell me, what do you understand from this grammar, right? So from this grammar, one thing we could understand is the highest, the E plus and star are defined at the same level. See, this is not a different level unless you go to the next one, F. Plus and star at the same level. Therefore, according to the grammar, plus and star are having same precedence, and then minus is written at a further away level from the start symbol. Therefore, the highest precedence will be given to minus, right? So in this plus star and minus, the highest precedence is given to minus, and if you look at the associativity, E is defined as left associative, and then F is defined as left associative. Sorry, E is defined as star is defined as left associative, therefore it is left recursive. Okay, star is defined as left recursive, therefore it is left associative, and then here plus is defined as right associative, therefore it is right recursive, therefore it is right associative. And if you look at minus is defined in both left recursive as well as right recursive, therefore here the precedence is this associativity is undefined. The grammar is again ambiguous, but one thing you could note is star and plus both are having equal precedence, and then here star is defined as left recursive, therefore leftmost star will get the highest precedence, which means star is left associative, and plus is defined as right recursive, therefore plus is right associative, and minus is defined as both left recursive and right recursive, therefore we cannot say which one is higher. We can generate either in the right side or the left side, therefore it could either be left recursive or left associative or right associative. Okay.